Hello everyone. So today we'll be making a laboratory activity regarding magnetism. So this activity we're going to make is in connection with Faraday's law, which states that a magnetic flux produces a current. As what Michael Faraday has experimented, he thrusted a magnet into a coil of copper wire and observed that there's a fluctuation of current, there's a production of current within the copper wire due to the magnetic flux of thrusting the magnet in and out of the copper wire, of the loop of copper wires. So in this experiment, we're going to need the following materials: a 12 volts DC power supply, LED lights. We have here a 12 volts motor, which attached on it is a pair of neodymium magnets. We have a gauge 32 magnetic copper wire. So a magnetic copper wire is just a copper wire which is coated with enamel in order to protect it from external factors, in order to coat the copper and protect it from, especially from oxidizing. And we have here I have extracted this one from a an old blender. So we have here a copper wire. Actually, I was thinking on extracting this copper wire here and making use of it and use it in a different platform, but since I think it's going to be a hassle, that's why I utilized this one. I just kept the copper wire. These are the loop of copper wires, so we don't need to make another coil of them. And what I have here on the external, this black one, it is actually a ferrite magnet. This one, if you can see. That's why I've attached this together with this material so that we can have a magnetic field around this circular material. In order to extend the reach of the magnetic influence of the magnet that we have here, the neodymium magnet, and overlap it with the magnetic influence of this one. So what we have here, we have this following two pair of wires. These are the ends of each copper wire. So this is copper wire number 1 and this is copper wire number 2. So I've just extended this with pair of wires in order to, in the later part, we're going to attach the LED lights within these wires in order to show and if whether our experiment or activity is successful or not. So I think that's it. So let's start. I'm just going to touch this one on the tripod. Oops. Okay, so let's start our work. So for demonstration purposes, I'm just going to show you how we should coil a copper wire. So just for example, we have here a copper wire, a magnetic copper wire which is enamel coated. So in order to produce loops of copper wire such as this one, we should just look for a mold. For example, this one, the Scotch tape. Then we're just going to loop that around and form a circle. So this copper wire will be induced with electric current once a magnet will be thrust in or out of this material, because it produces a magnetic flux which is in accordance to Michael Faraday's law, which states that a magnetic flux produces a magnetic field towards a copper wire. So we have this one. So the goal of the copper wire is just to produce a loop, such as this one. So we can utilize what I have here is a 32 gauge magnetic copper wire. So this is what I'm utilizing just for demonstration purposes. So that's how we loop the copper wire. So now we're going to assemble our material. So we have here, as what I've mentioned earlier, the material that I've extracted from an old blender. So what I'm going to do now is just, wait a minute. I'm just going to attach the other end of this neodymium magnet. So in order to increase the magnetic field and at the same time increasing the magnetic force, we're utilizing a pair of neodymium magnets attached to the top of this 12 volts DC motor. And what we're going to do is that we're going to put this here, and we're going to let this spin. And once this motor spins, it creates a magnetic magnetic flux. And in theory, in accordance to Michael Faraday's law, this will induce an electric current towards these copper wires here. So when an electric current is induced, it will light up the LED lights that we're going to attach in here. So now you get the whole concept of what we're going to do. So now let's just arrange this. Let's assemble this one. Okay, so now the challenge begins on how to attach this due to the strong influence of magnetic force upon these neodymium magnets. As you can see, pilit siya sa kuan ba? Pilit is metal. Okay, so now we're going to attach the LED lights towards the end of each copper wire. So we utilize 2 LED for each end. So we're just going to wrap them around here. So once the magnet starts moving, so there's a magnetic flux, a current is induced, and that current will flow into these LED lights, which will theoretically light them up. But if not, then this experiment is not a success at all, because that will just prove that there's no current flowing if these lights will not light up. Okay, so for the other end, oh, it fell down. To wrap this one. Okay, so all set. All that's left to do for now is to attach this thing into the 12 volts DC power supply, which is a battery of a motor. Success. Huwag mo siya. So hello guys, so as we can see in our previous experiment, the experiment was successful. We were able to light up only one out of the two LED lights. Why? I found out the reason. There's a fault within the other copper wire, the copper wire number two, because nabda siya samad, so it disrupted the flow of electric current. So if you're going to conduct experiments which involves copper wires, make sure that your magnetic copper wires are flowless. Wala siya kisi or unsa, because it will disrupt the flow of electrons of electric current, and it will reduce the efficiency. And in that case, as I've shown earlier, only one out of the two LED lights light up. But that still proved that our experiment was successful, because we were able to prove that the Faraday's law of magnetic flux that produces electric current is real. It is true. So that was just this experiment was all about producing an electric current through the fluctuations, through magnetic fluctuations. So that would be all, and thank you.